Welcome back, everybody. We are going to do Unit 2, Lesson 2 in this video. And really, this lesson is also serves as another intro lesson to our overarching topic of polynomials in Unit 2. So you might remember in the last video in Lesson 1, we talked about how we could use polynomials to model the volume of an open-top box. In this particular lesson, we're going to talk about how we can use polynomials to model the effects of different interest rates on investments. So how can we create a polynomial that models the effect of interest rates on investments? So we have a formula here, and then if we want to find how much money we earn, we have another formula here. I will talk about those as I go through this the examples. And speaking of examples, let's take a look at them. So at the end of 12th grade, Mary's aunt starts putting money in a bank account for her to use after graduating from college 4 years later. The first deposit was $300. If R is the annual interest rate of the account, then at the end of each school year, the balance in the account is multiplied by a growth factor of x equals 1 plus r. After 1 year of college, the total value is 300x. After 2 years, the total value is 300x squared. Write an expression for the total value upon graduation in terms of x. So, if we go back to our notes, to write the function that gives the total money after a certain number of years, it's going to be whatever the initial investment times x to the power of how many years it's collecting interest for. Now, if we're talking about how much money she has when she graduates, well, graduation is going to be how many years after 12th grade? It's going to be 4 years later, right? Because she has her freshman year, her sophomore year, her junior year, and her senior year. So to answer the question, write an expression for the total value upon graduation in terms of x. It's going to be 300 times x to the power of 4. 300x to the power of 4. And the reason reason the exponent is 4 is because it's collecting interest for 4 years. So her $300 investment is collecting interest for 4 years, hence 300x to the 4th. Number 2, if Mary's aunt had deposited another $500 at the end of her freshman year, write an expression for the total value of that deposit at the end of her senior year. So she initially deposited $300. That collects interest for 4 years. At the end of her freshman year, she deposits another $500. That is only going to collect interest for 3 years. So my expression is going to be 500, that's the new investment, times x, but now it's only going to be x to the power of 3 because that $500 investment is collecting interest for only 3 years. Number 3, suppose that $250 was deposited at the end of sophomore year and $400 at the end of junior year, in addition to the original $300 and the $500 deposited at the end of freshman year. Write an expression for the total value upon graduation in terms of x. So we can see here that her aunt is making a total number of investments of 4. She's making 4 different investments. So she first deposits $300, and that's going to collect interest for 4 years. That was the initial investment. She then deposits $500 at the end of her freshman year, and that collects interest for 3 years. What's the next investment? The next deposit or investment was $250 at the end of sophomore year. So that $250 deposit is now only going to collect interest for 2 years, hence 250x squared. And then the last deposit was $400 at the end of junior year. So if she deposits $400 at the end of junior year, then that $400 deposit is only going to collect interest for 1 year. So hence x to the power of 1, or we can just not write the exponent. If there's no exponent there, we assume it's to the power of 1. So we have a $300 investment that collects interest for 4 years, a $500 investment that collects interest for 3 years, a $250 investment that collects interest for 2 years, and a $400 investment that only collects interest for 1 year. If I want to know how much money does Mary have total when she graduates from college, what do you think I'm going to do to all these expressions? I'm going to add them together. So this polynomial, this is now a polynomial because it has 1, 2, 3, 4 parts to it, 4 terms, will represent the total amount of money that she has at the end of her college when she graduates. So this is the expression here. Number 4, if the interest rate was 3%, how much money was in the account at the end of the 4 years, meaning at the end of the 4 years of college? So to figure that out, let's go back to our lesson notes. Okay. So to find the total money here, it says to plug in 1 plus r for x, where r is the interest rate as a decimal. So for example, if the interest rate is 5%, I would plug in 1.05 for x. Okay. Now, in this case, the interest rate was 3%. So instead of plugging in 1.05, I'm going to plug in 1.03. So I'm going to take this expression, 300x to the power of 4 plus 500x cubed plus 250x squared plus 400x, and I'm literally going to plug in or replace x. So let me rewrite this first. So I'm going to plug in for x. I'm going to plug in 1.03. So I'm just plugging in 1.03 for x, and whatever answer I get, that's the amount of money that she has at the end of 4 years. So there's several ways you can do this. I think it's easy just to put this into Desmos. So that's what I'm going to do. So I'm going to go back to my Desmos app, and I can literally type it in exactly as is. So I have 300 times 1.03 to the power of 4 plus 500 times 1.03 to the power of 3. So 500 times 1.03 to the power of 3 plus 250 times 1.03 squared. So plus 250 times 1.03 squared, or to the power of 2, plus one more term, 400 times 1.03. And we can see here, if I just plug that all in, I just entered that all at once, and I got this total here. So this is going to be $1,561.24. So $1,561.24. $1,561.24. So that is how much money that Mary will have in her account at the end of her 4 years of college. And that is it for lesson 2.